Find the range of values of k. So this phrase means that your final answer has to be a range, meaning there will be inequality signs involved, okay, for which the equation, okay, the inequality must be in terms of k. I forgot to mention just now. The condition is that the quadratic equation, this quadratic equation, okay, which includes this side, so you got to make this into the form ax squared plus bx plus c. So that's the very first thing you need to do. Okay, they want this equation to have real roots. Now I need to explain what real roots are because some of you might have forgotten. Now whether it's real roots, two real and distinct roots, two real and equal roots, or no real roots, right? It all depends on this discriminant, which is the b squared minus 4ac. And where does this discriminant come from? It comes from your quadratic equation. Okay, so the thing that's inside the square root is what we call the discriminant, b squared minus 4ac. If b squared minus 4ac is greater than 0, then you can actually square root this value and you will end up with a value here. And because you have a plus and minus here, you will have two answers for your x, and that's why we call it two real and distinct different x values. But if b squared minus 4ac is equals to 0, that means this whole thing will disappear. So you plus minus 0 is still 0. That means you only have one answer. That's why this is called real and equal roots. That means there's only one answer and it's repeated twice. Lastly is when b squared minus 4ac is less than 0. That's when this is negative. You cannot square root a negative number, and that's why there is no answer for x. And that's what we call no real roots. Okay, so if you look at the phrasing of this question, they said real roots. They didn't say whether the roots are equal or the roots are distinct. So they only say real. That means it can either be this or this, which means that your b squared minus 4ac, the condition should be a combination of these two, so it's greater or equal to 0. Okay, so this is what this clue here is trying to tell you. Alright, but before we can do anything, we need to make this given equation into the form ax squared plus bx plus c, which is what I've done here. Okay, so you see k squared, a squared, right? This is your ax squared. There's no other x squared terms for you to combine. This whole thing here, which I put inside this bracket, okay, I like to make this sign positive and then throw whatever is the coefficient of x inside here. So if you take a look at this, originally on the left hand side of the equation, there's already a minus 2. Then this minus k, right, I have to make this side 0, so I minus kx here, I need to minus kx here. That's why minus kx appears here. And I'm only looking at the coefficient, which is the b, the constant b that I'm looking at. And finally, your plus c, the c is your 1. Okay, now that we have our a, b, and c, we can write down the condition which we just now have derived, and it is b squared minus 4ac greater than 0 or greater or equal to 0. Okay, now this part here must be very careful because some of you may not know how to handle this, although I mentioned in class already. Okay, now you must use the method that I taught you, which is to square this first term, minus 2, you square it, it is 4. Square this last term, minus k, you square it, it's plus k squared. And then you take minus 2 times minus k, that's plus 2k, then you times 2. That's why it's plus 4k. Those of you who try to memorize and then you see down here minus, then you thought that this is minus, right? Then you are wrong. Okay, so please use the method that I taught you. The method that I taught you is the general method. Okay, then minus 4ac, the a is k squared, the c is 1, and this is what you have. Simplify this, k squared minus 4k squared, you get minus 3k squared. And as I mentioned, always try to work with positive in this case it's k square, positive k square, so that it's not so confusing for you. So I change all these signs, and when I change all the signs, I'm actually multiplying a negative number to every term here, so I need to flip the sign. Okay, after this I'm just using calculator, and I find that these are the factors. Alright, and after that, let me just show you how to continue from here, because some of you still don't know. After you have found the two k values, which is 2, positive 2, and minus 2 over 3, okay, you need to ask yourself whether it is a happy or sad face. So I asked you to make it always positive, right? So it will always be a happy face. Okay, so if you can standardize this, then in your exam, in your test, right, you will always be drawing a happy face. Alright, and also your simplification, your factorization will be much simpler here. Alright, so please follow this recommendation that I have given to you. And now the next thing that you need to determine is, do they want this, on the left hand side is a quadratic curve, do they want the quadratic curve to be negative, which is in this case negative, or positive? So they want negative, right? So they want this part here, which means they want all the k values from minus 2 over 3 all the way to 2. They don't want anything less than minus 2 over 3. They don't want any k value more than 2. Okay, so this is your answer. But if you look back at the question, you must always check the question. Does this satisfy the condition? You always have to pay close attention to the coefficient of x squared. Why? Because if the coefficient of x squared is positive, then it's a happy face. If the coefficient of x squared is negative, then it is a sad face. Okay? Now, does it matter whether it's a happy or sad face here? It does not matter, because the question didn't say always positive or always negative. They didn't say things like that. Alright, they also didn't say, oh, this curve is always above this line or whatever. They didn't say that this coefficient here must be greater or less than 0. There's no condition for that. Alright, so whether it's positive or negative, it doesn't matter. But the pure virtue of this k square, whatever the k value is, will make this a positive value already. Okay? Yeah, so that settles it. But there's one thing that you need to take care of here, and that is, if you look at the answer that you derive, 0 is actually part of your answer for k. But we are told that this equation, this is a quadratic equation. So k cannot be 0. Because if k is 0, then this will no longer be a quadratic equation. So there is another condition that you need to, on your own, so-called realize that, oh yeah, k cannot be equals to 0. So you have to add in here, k cannot be equals to 0. So this is not the final answer. You put a comma there, k cannot be equals to 0. Okay? Now another way, so this is one way to present your answer. Another way to present your answer is, you need to avoid k, right? So another way to present your answer is minus 2 over 3. Then your k is until 0. It cannot be 0. Okay? It cannot be 0. Then, or 0, it cannot be 0. So, but it can be 2. Any number between this and this. Any number between this and this. Just cannot be 0. So that's another way. Okay? So that's how you can present your answer.